In this section, we're going to create pseudocode which will allow us to delete a node from within a linked list. This is, again, an unordered linked list, and we're going to use the same example as we've used all the way through so far. So the first thing we need to do is explain the heading. So a delete node takes in a parameter called data item, and that is the letter that we're looking for and we're going to delete when we find it. So the very first thing we do is we look. So let's say we're searching for E, for example. So here we see we set up two pointers. One is the pointer of the node that we want to delete when we find it, and we also want to store something called previous pointer because we need to know details about the node just before the node that we want to delete. So we start off by setting delete pointer to be the start pointer, so it starts off with 0, so it'll start H. And then just like every other conditional loop that we have with linked lists, we start by checking that the delete pointer is not the null pointer, because if it is the null pointer, it's reached the end of the valid linked list and it should stop. But we also want to say that if the delete pointer is not null and the data item of the current pointer is not the data item that we want to delete, then we set the previous pointer to del pointer, and then we get the next pointer in the linked list. So let's just run through this very quickly. First of all, I am just going to quickly just make sure that that has got the correct value, because it's a null pointer at the end of O. Because we've got two lists there, we've got the linked list and we've got the free nodes linked list, so they should both have null pointers at the end. If we were searching for example, E as the data item, we set the del pointer to be 0, which is the start pointer, as you can see, and then we say that while del pointer is not null, it's not null, and the my list of del pointer, which is this node here, the data item is that not what we're searching for? Well, we're searching for E, so that's not E. So we then set previous pointer to be whatever del pointer is, which makes that 0. And then we have to change del pointer to be the pointer to the next node, which in this instance is 1. And then our while loop continues, and we look at 1, it's not null, but it is the data item, so there we stop and we drop out. So at this point, previous pointer is 0, del pointer is 1. We then do some testing. So the first thing we do is we check that del pointer is not null pointer, because there is a risk that we get all the way through to the end of the linked list and we don't find the item that we're looking for. So therefore the last, the del node will be -1, or del pointer will be -1. So we want to make sure that it's not that, because if it is null pointer, we can't delete anything, there's nothing to delete. So if it's not null pointer, we then check to see if it's the very first node in the list. If it's equal to start pointer, we also need to change this variable here to be what the current node is pointing to. Let's just move this up here so we can still use it. Okay, now we have more space. So if the del pointer is the start pointer, okay, it's not in this instance, but let's say it was, then you set the new start pointer to be the current start pointer's pointer, so it will point to the next node, so E becomes the first node in the linked list rather than H, for example. If it's not the start pointer, then we can simply take the previous node's pointer and link it to the next node instead. Okay, so this is what we're going to do with our example here. So we're going to look at the previous node, we are going to get its pointer, and we're going to change that pointer to be equal to the pointer for the node that we're trying to delete. So we're basically changing 1 to 2. And so this is the code that does that. The last thing we have to do, let me just update the blue part. Okay, the last thing we have to do is we have to take the node here and we have to add that to the free node list. Now, it's quite hard to add it to the end of the free node list. So what we do have access to is the start of the free node list. So we can actually manipulate it so that free pointer now points to this, and this links to what was previously free pointer. And so what these two lines do is it will change the pointer of the node where we've got the E to be the free list pointer. Okay, so it points to 5, and then the second line changes the value within free pointer to 1 because that's the position of node E at the moment. We don't delete the letter E from the data item because if we use that node again by inserting a new node, it will overwrite the value, and that saves us a process. So we can just finish the end if, and then we can end the procedure.